This video introduces Yolo 9000, which aims to be better, faster, and stronger in object detection. The initial Yolo model provided a good balance of speed and mean average precision, or MAP, compared to other detection methods. Yolo's speed at 45 frames per second was a major advantage, significantly faster than R-CNN and fast R-CNN methods. However, Yolo's MAP of 63.4 was lower than other state-of-the-art detectors, indicating room for improvement in accuracy. Despite lower MAP, Yolo was capable of real-time object detection, achieving 29.2 frames per second in this demo from CVPR 2016. The goal is to follow the mantra, work it harder, make it better, do it faster, which makes us stronger. First, let's look at how to make it better, focusing on improving accuracy for the Yolo model. The original Yolo training involved pre-training a classifier on ImageNet, resizing the network, and then fine-tuning on detection datasets. By fine-tuning the 448 by 448 classifier on ImageNet data after resizing, we gain 3.5% MAP. Anchor boxes in object detection usually rely on static initialization with predefined sizes and aspect ratios. To improve initialization, we use k-means clustering on the training bounding box dimensions to find better anchor box shapes. Dimension clusters derived from k-means better represent typical object shapes compared to standard anchor boxes. Using these dimension clusters leads to a significant gain of 5% MAP for Yolo. Multi-scale training, where images of different sizes are input during training, further improves MAP by 1.5%. Yolo 2 achieves fast and accurate detection, with versions outperforming Yolo's original speed and precision. Various object detectors exhibit a trade-off between mean average precision and GPU time or speed. Real-time performance is generally considered to be detectors that operate below a certain GPU time threshold. Yolo 2 operates on the real-time boundary, showing excellent speed accuracy trade-offs compared to other models. Yolo 2 demonstrates performance gains in both accuracy and speed in the real-time region of the performance curve. Now we address the do it faster part, focusing on improving the speed of the Yolo model. Speed in deep learning isn't just about parameter counts or floating point operations per second, but actual inference time. DarkNet 19, a custom network architecture, is designed to strike a good balance between speed and accuracy for Yolo 2. DarkNet 19 replaces the custom network used in the original Yolo. It uses 19 convolutional layers and 5 max pooling layers. DarkNet 19 achieves 72.9% top 1 accuracy and 91.2% top 5 accuracy on ImageNet. The architecture is optimized for fast inference. To achieve Yolo 9000, we combine data from ImageNet's 14 million images and 22K classes with COCO's 100K images and 80 detection classes. Classification models usually employ a softmax function over all classes to predict probabilities. Combining the class labels directly is complicated because detection and classification classes are not mutually exclusive. For example, a dog detection class overlaps with many specific dog classification breeds. The labels have different granularities. Dog is general, while terrier is specific. We need a structure to combine the large number of classification classes with the detection classes. WordNet provides a hierarchical structure, but it is complex and messy for direct use. We construct a hierarchical tree, called word tree, to merge the ImageNet and COCO classes. The word tree combines concepts into a single structured hierarchy. Each node in the word tree represents a conditional probability relative to its parent node. The probability of a specific class, like, quote, Bedlington Terrier, is calculated by multiplying conditional probabilities along the path to the root. Yolo 9000 integrates word tree for simultaneous detection and classification over 9,000 categories. The detection dataset provides bounding box information, while the classification dataset adds a vast number of class labels. Yolo 9000 is a significant step towards general, wide-ranging object recognition. The model detects objects and classifies them into one of the 9,000 classes using the word tree structure. Yolo 9000 demonstrates high performance on object detection datasets, even for classes not seen during detection training. The model effectively generalizes from classification data to detection tasks. Yolo 9000 is faster and more capable than other large-scale object detection systems. This concludes the video on Yolo 9000, which is better, faster, and stronger in object detection.